Hi students, so let us move to the next chapter, that is the application of derivatives. So till now we came across the chapter of derivatives, differentiation, how we are differentiating a certain functions, and all these things we have came across till now. But in the application of derivatives, what we are learning here is how these derivatives are useful, in how we are going to use this derivatives, the application or the uses of this differentiation. So in this chapter we are going to deal with the first thing, that is the rate of change of a quantity. How a given or any quantity, if I consider any quantity, means how this quantity is going to change with respect to the some other parameters with respect to time. So rate of change of a quantity, that is the first thing we are going to learn. Then increasing and decreasing function. So what is this increasing and decreasing function? If f of x is increasing as the x value increases, means then we call it as an increasing function. Suppose if f of x value is going to be decreases as the x value increases, means then we are going to call it as a decreasing function. So through the derivatives we are going to determine whether the given function, whether it is an increasing function or a decreasing function. So this is one of the application when it comes with the application of derivatives, that is determining whether the given function is increasing or decreasing. The next is we are going to find the equation of tangents and norm. So suppose if they have given any curve, and at a given point, say this point, if we draw the tangent, means we are going to, with the help of this derivatives, by the differentiation we are going to able to find the equation of this tangent. And suppose if I able to draw the norm, means at the given point, means then the equation of this norm. So at a given point in on the curve we are able to find the equation of a tangent and a norm with the help of this differentiation. So this is another application of derivatives. And then maxima and minima. Suppose if they have given any curve, and in that curve there will be obviously one of the maximum point and the minimum point. Suppose if I draw the curve like this, if this is a maximum point, means so through the help of derivatives we are able to find the maximum point. And if there is a curve like this, and if this is a minimum point, means then we are able to find the maxima and minima. This point is called as a maximum point, and the corresponding point to that maximum point, this is called as a maxima. And this point is a minimum point, and this corresponding value to that minimum point, this is called as a minima. So this is we are going to find the maxima and minima with the help of derivatives or the application of derivatives. So these are the basic things which we are going to study in this application of derivative chapter. So these are we are going to cover up in this chapter. So let us go through each and every concept step by step. Through each in detail we can go each and every concept. So in that, first thing is the rate of change of quantity. So what is this quantity? I can take any quantity. So the quantity, it might be an area, it might be a volume, it might be the cost price, or it might be some of the surface area, whatever it might be. Quantity means I am considering any quantity here. Okay. So suppose in particular if I consider now area. So in particular I am talking about the area of a circle. So this is a circle I have considered. So I am considering the area. So what is the area of circle? Area is equal to pi r square, where r is the radius of the circle. So this is the basic thing which we all know about it. So this is an area of the circle. So now how this area changes? How this area, the area is not going to change automatically. There is something upon which the area is going to change. So you can see area is equal to pi r square here, where pi is a constant. So clearly a is directly proportional to the radius of the circle. So as the radius is going to change, the area is also going to change. As the radius increases, the area might be increasing, and as the radius decreases, area is also going to decrease. That is area of a circle. So clearly area is directly proportional to the radius. So as the radius is going to change, the area is also going to change here. So here r, it is a parameter. So a quantity, area is a quantity which is going to change with its parameter. So that is nothing but here area is going to change with respect to the radius. So this is nothing but rate of change of area with respect to radius. So in general, if I am able to write this one, means that is, what is this rate of change of a quantity, means that is nothing but dq by dp. So what is this q here? Here q, it is a quantity. It might be any of the quantity. And what is this p? P, it is a parameter. So what is the meaning of this parameter? Clearly parameter means it is nothing but it is a one of the variables. So in case if I considered here area is equal to pi r square, means here r, it is a parameter. Why it is a parameter? Because it is a variable upon which the area is depending. So here clearly area is dependent upon which one? Here area is depending upon the radius. So here r is a parameter upon which the area is depending. So parameter means it is one of the variable upon which the quantity is going to depend. So that is what the meaning of parameter is. So here the rate of change of an area. So we have observed here the change in the area of a circle is observed with respect to which one? It is observed with respect to a parameter, that is a radius. So dA by dr is nothing but rate of change of an area with respect to the radius. So the quantity, the rate of change of quantity, that is dq, it is observed in the two ways. One is the quantity is going to be changed with respect to the parameter. That is what we have observed here. The area is going to be changed with respect to the radius, because radius is the parameter in the given taken example which I have taken here. Another thing is the quantity is going to be changed with respect to the time. That is nothing but here radius is going to be varied. So as the time varies, the radius is also going to be varied. Upon the radius is going to depend upon which one? The radius is going to depend upon the time changes. So how we are going to evaluate this one? In this case we are using here chain rule. So chain rule is used to evaluate the rate of change of quantity with respect to time. That is nothing but dq by dr into dr by dt. So you will get to know the clear use of this one, how it is going to be varied when we are going to solve the problem upon this one. So upon briefing this part, it is clear that the rate of change of a quantity is nothing but here the quantity is going to be changed with respect to one of the parameter. So we can see here the parameter in the given example, it was a radius. So rate of change of a quantity with respect to a parameter. The rate of change of a quantity is the rate of change of a quantity, it can be solved in the two ways. One, it is changing with respect to the parameter. Another one, it is changing with respect to the time. Suppose if I am going to write, that is rate of change of area, that is equal to dA by dr. It is nothing but change in area divided by change in the radius, right? So it can be also written as, observe here clearly, change in the area with unit change in the radius. That is nothing but dA by dr. So what does this implies? So here our area is equal to pi r square. What is dA by dr? dA by dr is nothing but 2 pi r. That is nothing but dA by dr. Suppose if there is a 1 unit change, whatever the unit it might be given here, if there is a 1 unit change in the radius, it might be from, it was a 3 centimeter, 3 to 4 centimeter, or 4 to 5 centimeter, or 3 to 2 centimeter. If there is a small changes, that is a 1 unit changes in the parameter, that is here radius. If there is a 1 unit changes in the radius, means there is a changes in the area. So that is what it is going to say. The change in the area with the unit change in the radius is nothing but the rate of change of a area also. So this is a different way of saying the rate of change of a quantity. So here I didn't mention quantity, I have talked in particular about area, so that you will get some better idea than talking it generally. So you can generalize yourself for any of the parameter. or any of the given quantity with respect to its parameter. So this is what the rate of change of quantity is going to be set. So now let us solve some of the problems regarding the rate of change of a quantity so that you will get a clear idea about what I have discussed right now. So here is the question. Find the rate of change of area of a circle per second with respect to radius when r is equal to 5 centimeters. So first thing, they have asked about the rate of change of area of the circle. First you should know what is the formula of area of the circle. So what is the area of the circle formula? It is nothing but pi r square. And what they have asked? They asked about rate of change of area of a circle per second with respect to radius. So we are going to find the rate of change of an area with respect to which one? With respect to its parameter, that is a radius. So we are going to differentiate, find the rate of change of the area with respect to radius. So what is that? With respect to areas means we are differentiating the area with respect to radius. So what is the differentiation of this one? This is 2 pi r. What they have asked? They asked find the rate of change of area with respect to of a circle per second with respect to radius. At they are only given at when the radius is equal to 5 centimeters. So we are going to find the rate of change of area with respect to radius at r is equal to 5 centimeters. So what? 2 pi r value it is 5. So what happens? 5 2s are 10 pi. So what is this one? Rate of change of area with respect to radius. So what is the area? Centimeter square per second. Remember to put the unit, guys. You are carrying the 1 marks over that unit also. So remember to put that unit. So this is how we are finding the rate of change of area with respect to the parameter. So here is the next question. Here they are asking the radius of a circle is increasing uniformly at the rate of 3 centimeter per second. So here they are saying the rate of change of radius of a circle, it is increasing uniformly. When they are saying the radius rate of change of area or the radius of a circle is increasing uniformly with the rate. So when we are saying it is increasing means at that time we are taking the positive value. When they are saying decreasing means at that time we are taking the negative value. So here they have said the radius of a circle is increasing uniformly at the rate at what? 3 centimeter per second. So what they have given? The rate of change of radius with respect to time they have given. What is that? 3 centimeter per second. Since it is an increasing, so I am taking the positive value. Suppose if they have said decreasing means I have taken dr by dt is equal to minus 3 centimeter per second. Then what they have asked, find the rate at which the area of the circle is increasing when the radius is 10 centimeter. So we need to find the rate of change of area. But we don't know with respect to which one. So we need to find whether this one rate of change of area with respect to radius or rate of change of area with respect to time. So here if I go with this one, if I go with rate of change of area with respect to time, since it is circle, area is pi r square. So differentiating this one with respect to area means what happens? 2 pi r. But what they have given, they have also given there is a rate of change of radius with respect to time. So we cannot adopt this one. So we are finding the rate of change of area with respect to time. So what happens? That is dA by dr into dr by dt. So what is dA by dr? It is d by dr of pi r square into dr by dt. What is dr by dt? It is 3 centimeter per second. So it is 3. So pi r, it is nothing but 2 pi r into 3, which is equal to 6 pi r. So we got the rate of change of area with respect to time. But what they have asked, we need to find the rate at which the area of the circle is increasing when the radius is 10 centimeters. So they are asking this one at when r is equal to 10 centimeters. So substitute here. What happens? 6 pi into 10, which is equal to 60 pi centimeter square per second, because here radius is given in the centimeter and time is given in the second. So 60 pi centimeter square by second. So this is the rate of change of area with respect to time. So remember guys, when the parameter when the given parameter, if that is changing, if the parameter is changing with respect to time means, then the given quantity which we need to find the rate of change of the given quantity, that is also calculated with respect to time itself. That is rate of change of quantity. You can see here the parameter of the circle, it is radius. So here radius was changing with respect to time. So the rate of change of area, that is the quantity, here it is area. The rate of change of quantity is also calculated with respect to time itself. So remember this one in the form of a note, so that might be helpful. If the parameter is changing with respect to time means, then the quantity which we need to find the rate of a quantity, given quantity means, even that is also we are going to calculate with respect to time itself. The next question is, so it is the application type of question. There will be certain questions which are asked like a day-to-day life general example which we need to imagine. So here is one question of like that: a stone is dropped into a quiet lake. So there was a quiet lake where water was not disturbed, so stone is dropped into that lake. So what happens when we drop a stone into a quiet lake where there is a no disturbance means, when we drop a coin or drop a stone or anything means, a wave is formed. So here that wave is moving in a circular form. So what the wave is formed, it is moving in a circular form when we drop a stone in that. So that in the moving it in the circular form at a speed of what? At a speed of 4 centimeter per second. At that instant, when the radius of a circular wave is 10 centimeter, how fast the enclosed area is increasing. So what they are saying is, when we drop a stone into a quiet lake, it forms a wave, and that wave is moving with the speed of 4 centimeter per second. So wave is moving with the speed of 4 centimeter per second means, what it is, the radius of that circular, it is going to increase up at the speed of 4 centimeter per second. So what is this 4 centimeter per second they have given? They have given is rate of change of radius with respect to time, that is 4 centimeter per second. That is what they have said, that it is moving in a circular with the speed of 4 centimeter means, has the circular that is going to be increasing, the radius is going upon increasing. So that is going to be increased at what rate? 4 centimeter per second, since they have said speed moving at the 4 centimeters per second. That is what I have written. At that instant, when the radius, they are saying at the radius at 10 centimeter, when radius is 10 centimeter, what is how fast that area is going to be increasing. So we need to find what here? Rate of change of area with respect to time, because here parameter itself is changing with respect to time means, the quantity is also going to be changed with respect to time. So dA by dt is nothing but dA by dr into dr by dt. So what is the area of the circle? It is nothing but pi r square. So dA by dr it is 2 pi r, and dr by dt it is 4. So 4 into 2 it is 8 pi r. They said that find the how fast that area is increasing when radius is 10 centimeter. So they are talking when r is 10 centimeter. So substituting here 8 pi into 10. So what we are going to get? 80 pi. What is that? Centimeter square per minutes, not minutes, it is second, because the quantity it is given in the second here. So 80 pi centimeter square per second. So this is the rate of change of area with respect to the time. So this is how we are going to find. So the thing is that this, since it is an application of an derivatives, or it is talking about an application, so we are going to have this day-to-day life regular general example like type of question. So where you need to imagine that question first, and to understand what they are asking about, which is that here see, this they just said it is moving with the speed of 4 centimeter per second. So you need to recognize what is this 4 centimeter per second they are talking about. So since they are talking about the circle is moving at that speed, so circle is moving means they are talking about the rate of change of radius with respect to time. So this is how we are going to identify in each type of the question. So the next question is, the length x of a rectangle is decreasing at the rate of 3 centimeter per minute. So they have considered one of the rectangle over here. I am considering that rectangle. So they have considered the length is of x centimeter. Yeah, it is of x centimeter. Okay, they are saying what the length x of a rectangle, it is decreasing at the rate of what, 3 centimeter per minute. So per minute means here the rate of change of x with respect to time. So the length is changing with respect to time. What they are saying that the length of the rectangle is, it is decreasing, as they have said decreasing. I am writing here minus 3 centimeter per minute. Okay, then width y, they have considered the width is equal to y. They are saying that the width y is increasing at the rate of 2 centimeter per minute. So the width is increasing, so even it is 2 centimeter per minute. So they are talking about the parameter y, it is changing with respect to time. So dy by dt is what, 2 centimeter per minute, because they have said it is increasing, so I am taking the positive value. After that they are saying at x is, when x is equal to 10 centimeter and y is equal to 6 centimeter, let it be like this. We don't know how to use this one at right now. Find the rate of change of perimeter and the area of a rectangle, they are saying. So when it comes to perimeter, don't confuse with the parameter and the perimeter. Okay, so as I explained already, that is what is parameter. Is parameter, it is a variable upon which the quantity is depending. What does the perimeter is saying? Perimeter is the outer area, outer length. We are taking about total length of the outer surface here. So what is the perimeter of this one? Here perimeter of the rectangle, it is 2 times x plus y. This is the perimeter of the rectangle. Suppose if I am talking about the circle, means what is the perimeter of the circle? It is 2 pi r. So that is what, that is the outer length of the outer surface length of the given any which shape they have talking about, that shape outer length it is, that is nothing but the perimeter is. So here they are asking rate of change of perimeter. So we need to find the rate of change of perimeter. So clearly perimeter is 2 times x plus y here, because it is a rectangle. So they are asking what is the rate of change of perimeter. So your question might be thinking, here we are having two parameters, say x and y, upon with respect to which parameter we need to find the rate of change of perimeter. Whether we are going to find rate of change of perimeter with respect to the parameter x, or whether we are finding rate of change of perimeter with respect to the parameter y, or we are finding rate of change of perimeter with respect to the time. So you can observe here clearly that in the beginning itself they have given there is a rate of change of our parameter x and y with respect to the time. So when the parameter itself is changing with respect to time, obviously our perimeter is also changing with respect to time. So we are finding the rate of change of perimeter with respect to time. What happens this one? It is nothing but dx by dt plus dy by dt. Now what is this dx by dt? We are already having, it is minus 3, and what is our dy by dt? It is 2, minus 3 plus 2, it is minus 1. So minus 2 centimeter per minute. So this is the rate of change of perimeter with respect to time. Suppose if you are going to state it verbally, means here the rate of change of perimeter, it is decreasing at the rate of 2 centimeter per minute, because we are having here negative sign. So the rate of change of perimeter, it is decreasing, the perimeter is decreasing at the rate of 2 centimeter per minute with respect to the time. This is how we are going to state the this answer verbally. Then next they are asking about what is the rate of change of area of a rectangle. So when we are talking about the rectangle, means obviously the area of rectangle is length into breadth, that is area is equal to x into y. So we need to find what now? Rate of change of area. So obviously our parameter x and y both are changing with respect to time. So even our area is also changing with respect to the time. So what happens here? D by dt of x into y. So here we are having the product of two parameter. By using the product rule, what happens? First function differentiation of the second function plus second function into differentiation of the first function. So in the question itself they have given, that is dx by dt, it is equal to, this is decreasing, minus 3 centimeter per minute, and dy by dt is equal to what? 2 centimeter per minute. So what happens here? X into what is dx by dt, it is 2, plus y into what is the value of dx by dt, it is equal to minus 3. So what happens here? 2x minus 3y. So this is what? Rate of change of area with respect to time. But they said that when x is equal to 10 centimeter and y is equal to 6 centimeter, we need to find the rate of change of perimeter and rate of change of area. So in the perimeter we didn't had that opportunity, we didn't got x and y variable, but here when they are talking about the area, so they are talking when x is equal to 10 centimeter and y is equal to 6 centimeter. Substitute here, what we are going to get? 2 into 10 minus 3 into 6. So that is nothing but 20 minus 18, which is equal to 2 centimeter square per minute. So this is the rate of change of area with respect to the time. So this is how we are going to calculate the rate of change of a quantity with respect to the any other parameter or with respect to the time. So this is regarding some of the examples based upon this rate of change of a quantity. So when we are dealing with like this type of question, you should be thorough with your basic formulas. Basic means purely basic, completely learnt in your elementary classes, that is area and volumes of circle, rectangle, square, cube, conic and sphere, cylinder, trapezium. So regarding all these things, the area, all these things, area and volume, you should be thorough with all these things. So be thorough with all those basic formulas. Some certain times the question might be arise based upon the commerce type of question. So there is one example so that you can get some idea. So here is one of the question, that is the total cost in rupees associated with the production of x units in the item is given by what? C of x is equal to 0.005 x cube minus 0.02 x square plus 30x plus 5000. So this is what? That is the total cost of some production of some item. So how much that item is produced? That item is produced in x unit. When that item is produced in the x unit, the cost price of that item they have given is in this manner. What we need to find? We need to find the marginal cost when 3 units are produced. Here, by looking into the marginal cost, you might think, what is this marginal cost? Here, marginal cost means instantaneous rate of change of total cost at any level of output. That is nothing but rate of change of cost with respect to what? How many outputs are given. So it is nothing but marginal cost is nothing but rate of change of cost with respect to the output. Here in the given example, what is the output here? Here output is x. So rate of change of cost with respect to the output. So what we need to find here? We need to find that marginal cost itself. So marginal cost is dc divided by dx. So what is that? d by dx of 0.005 x cube minus 0.02 x square plus 30x plus 5000. So if we differentiate this one, what we are going to get? That is nothing but 0.005 into 3x square minus 0.02 into 2x plus 30. So this is what we are going to get. But what they said, and we need to find the marginal cost when 3 units are produced. So at when x is equal to 3 here. So what happens? Substitute that one, 0.005 into 3 square, it is 9 minus 0.02, 3 2s are 6 plus 30. Upon adding all these things, we are going to get 30.02 approximately we are going, this is the marginal cost of the given thing. So this is how we are going to find the things when the questions are given in the commerce type of way. When the commerce students read this question, they will feel it easy, but when we people start to read, we find what is this marginal cost, how this question is given. So to get that idea, I have solved one of the questions. So go through this question clearly and thoroughly with all the concept what I have explained in this video. Suppose if you have any doubts regarding the rate of change of quantity, means you can ask me at any time. Thank you, students.